Good afternoon, everyone.
Good afternoon,
As
sir.
you are aware of that this is the session for MMPC-005. Today we will be discussing about block 3, that is sampling and sampling distribution, which again consists of 4 units, unit 9, 10, 11 and 12, and that pertains to sampling methods, sampling distribution, testing of hypothesis and chi-square tests. These topics are basically related to analysis, some mathematical concept, and some new theory which you might have not heard of or you might have not paid attention to it. So I will be starting with unit 9, that is sampling methods. So first of all, we will see what are the fundamentals of sampling methods are. So what is basically it consists of. As far as introduction is concerned, when one is interested in measuring some attribute of a large or finite group of elements by studying only a part of that group. That is simple. We are talking something about sampling. This process of interpreting something about a large group of elements by studying only a part of it is referred to as sampling. Now the thing is that how to understand what sampling is, what are the terminologies, what are the things included into it, and how do we say that we are doing sampling? There are n number of questions. The maximum part will be covered today to make you understand how, what, what are the different kinds of sampling are. We will have introduction of everything. Suppose now we take up an example of bank. Now question arises, bank for what? So we will see. We take up an example of Bank of India. Is the slide visible to you?
Yes, sir.
Okay. Now you can see that it is written over there. We are talking about Bank of India. Now we have to measure the level of employee motivation. We administered a questionnaire to 250 employees from different branches and offices all over the country of its 30,000 employees. Now, keep that thing, that concept in mind. First of all, the thing is that what is meant by population? That is collection of an element about which some inference is to be made is a population. Any characteristics of a population will be referred to as parameters of the population. Some population parameter is by studying only a part of the population, that is sample. Any characteristics of a sample is called a statistic. Now see, you can see a rectangle over there and an oval shape at the center, which is blue in color. Your parameter is the motivation level of the population, yeah, the motivation level of the bank employees. Your population is 30,000 employees of the bank. Your sample size is 250 employees taken randomly. Statistic, the concept is what? Motivation level of the sample. Celsius or complete enumeration of the population. That is complete what we are talking about. Now, this is the different terminologies what we are going to use or what we will be using and what has to be used. When we talk in terms of population, that is parameter. Population size is taken as n. You might remember something what we discussed yesterday. Population size is n. Population mean is mu. Population standard deviation is sigma. And population proportion is capital P. It's not going to change. You have to differentiate. Every time in the numerical part or the theory part, it won't be difficult again and again to say that thing. You have to keep this thing in mind. And when we are talking about a sample, in that parameter is converted into statistic. Your population size is converted into sample size, and that is small n. Your sample mean is x bar. Your sample standard deviation is s, and your sample proportion is small p. But this is the basic difference. This difference will be shown to you in your numerical problems. Why? What is the need of sampling? Time taken for the study, cost involved for the study, physical impossibility of complete enumeration, practical infeasibility of complete enumeration, enough reliability of inference based on sampling, and quality of data collected. Now, what are the different types of sampling? There are two basic types of sampling depending on what or who is allowed to govern the selection of the sample. The first one is probability sampling. Each element of the population has the same non-zero probability of getting included in the sample. The second one is non-probability sampling. There, samples may be picked up based on the judgment or convenience of the enumerator. Now, what are the different methods of probability sampling? Simple random sampling, systematic sampling, stratified sampling, cluster sampling. Simple random sampling. Under simple random sampling, each element of the population has an equal probability of getting included in the sample. We had a discussion yesterday about the probability. So keep that thing into your mind. All other forms of probability sampling use this basic concept of simple random sampling, but apply to a part of the population at a time and not to the whole population. Now, probability you are aware of. We will be using two formulas, two symbols, that is NCN or NCR, because in probability we use NCR, but here in sampling we will use NCN, that is capital N and small n. Small n is for the sample size and capital is for the population size. Random sam- random Simple random sampling ensures that any one of these samples has the same probability of being picked. Yesterday we were talking about toss of a coin. There were two outcomes, either tail or head. The question was, what is the probability of getting a head? So what we did, 1 upon 2. So here NCN is that 2. Systematic sampling. Systematic sampling proceeds by picking up one element after a fixed interval depending on the sampling rate. Keep that thing in mind, what we will be doing. We will be using this in strata. For example, for a sample size of 10, from a population of size 100, our sampling ratio would be small n by capital N. That means 10 by 100, which comes out to be 1 by 10. So that means we will start numbering from 1, and after leaving 10, either we can start from 1 or we can start from 2. The number choice is yours. But the second element will be after a gap of 10. Suppose here we take up numbers, suppose 1 to 100. We started from 7. So our first sample number will be 7, and the second will be 17, and the third will be 27, and the last one will be 97. That means leaving 10. Now comes stratified sampling. The basic idea behind stratified sampling is to divide the whole heterogeneous population into smaller groups or subpopulations, such that the sampling units are homogeneous with respect to the characteristics under study within the subpopulation and heterogeneous with respect to the characteristics under study between or among the subpopulations. Such subpopulations are termed as strata. Treat each subpopulation as a separate population and draw a sample by SRS from each stratum. Now see what is actually meant by strata. Stratified random sampling is a method of sampling that involves dividing a population into smaller subgroups called strata. The groups of strata are organized based on the shared characteristics or attribute of the members in the group. The process of classifying the population into groups is known as stratification. Now, what actually we are doing? You can see that there are three strata, stratum 1 to 3. Number of elements in them is 200, 300, 500. The sum is 1000. And your sample size is 10, 15, 25. And now the question is, what is your sampling ratio? 1 by 20, 1 by 20, and 1 by 20. So overall, what is going to happen? 50 by 1000 will be 1 by 20. And your sampling ratio is 1 by 20. So you can see that there is an oval. It is being divided by three lines. So the whole system is being divided into four parts. So this is basically what we are doing in stratified sampling. See to it that the ratio, the sampling ratio is 1 by 20 throughout. This proportional stratified sampling. If the different strata in the population have unequal variance of the characteristics being measured, then the sample size allocation decision should consider the variance as well. It would be logical to have a smaller sample from a stratum where the variance is smaller than from another stratum where the variance is higher. What does that mean? Now you can see over here what we are doing. If sigma 1 square, sigma 2 square, sigma 3 square are the variance of the population piece respectively, then the statistical efficiency is the highest when what we are doing, the same problem is there. Now stratum variance is given to you. This is 2.25, 4 and 0.25. Stratum standard deviation will be under root of it, 1.5, 2 and 0.5. Sampling ratio will be now has been changed because it's not uniform. 13, 26 and 11. Now your sampling ratio will be 0.065, 0.087 and 0.022. This is not proportional. Cluster sampling. The colony is divided into 11 blocks. Each block from A to K. Suppose we have what we I don't know in which part of city you people are living. Suppose we take up a locality. If we talk about any locality, if we take a locality as an example of Nagar, so there are different blocks. There are sectors, but there are different blocks. Depending upon the block, that is basically a government residential place where different types of flats are made. But in a particular block, single type of flats are prepared. Similarly, Colony is divided into 11 blocks, block A till K. Cluster sampling is used in this situation by treating each block as a cluster. Two blocks are selected out of 11 blocks at random, and their information is collected from all the families residing in the two blocks to come to the conclusion. Now the thing is that what is the difference between cluster and stratum? Strata are homogeneous within and different from other strata. Clusters should be heterogeneous within and the different clusters should be similar to each other. A cluster is a mini population and has all the features of the population. The criteria used for stratification is a variable associated with the characteristics measure. Convenience of data collection is usually the basis for cluster definition. And there are very few strata, but there are many clusters. Multi-stage and multi-phase sampling. Multi-stage sampling is where the sampling unit is something larger than an individual element of the population in all stages but the final. Multi-phase sampling is designed to make use of the information collected in one phase to develop a sampling design in a subsequent phase. A study with two phases is often called double sampling. Convenience sampling. In this type of non-probability sampling, the choice of the sample is left completely to the convenience of the interviewer. The cost involved in picking up the sample is minimum and the cost of data collection is also generally low. For example, the interviewer can go to some retail shops and interview some shoppers while studying the demand for non-irritated beverages. Purposive sampling. In convenience sampling, any member of the population can be included in the sample without any restriction. When some restrictions are put on the possible inclusion of the member in the sample, the sampling is called purposive. That means basically for a particular purpose. Judgment sampling. In judgment sampling, the judgment or opinion of some experts forms the basis for sample selection. The experts are persons who are believed to have information on the population, which can help in giving us better samples. Such sampling is very useful when we want to study rare events, or when members have extreme positions, or even when the objective of the study is to collect a wide cross section of views from one extreme to the other. Quota sampling. Even when we are using non-probability sampling, we might want our sample to be representative of the population in some defined way. This is sought to be achieved in quota sampling so that the bias introduced by sampling could be reduced. For example, family size could be another criteria, and we set up quotas for families with family size up to 3, between 4 and 5, and above 5. However, if the number of such criteria is large, it becomes difficult to locate sample members satisfying the combination of the criteria. Now, sample size. One of the most important factors that affects the sample size is the extent of variability in the population. Taking an extreme case, if there is no variability, that is, if all the members of the population are exactly identical, a sample of size 1 is as good as sample of 100 for the other number. A second consideration is the confidence in the inference made. The larger the sample size, the higher is the coincidence. In many situations, the coincidence level is used as the basis of to decide sample size. Now comes sampling distribution. The question arises, what is sampling distribution? In general, the sampling distribution of a given statistic is the distribution of the values taken by the statistic in all possible samples of the sample size from the same population. Or in other words, we can say that if we repeatedly collect samples of the same sample size from the population, compute the statistics, that is mean, standard deviation, proportion, and then draw a histogram of those statistics. The distribution of that histogram tends to have is called sampling distribution of the statistics. Sampling distribution of means and central limit theorem. Now actually something till now it was the theory part. Now from this onwards, mathematical component, mathematical things will start. Sampling distribution of sample means from a normal population. Theorem 1 is let X be the sample mean of the random sample of size drawn from a population having mean n and standard deviation s. Then the mean of x bar is mu x bar is equal to mu, and the standard deviation will be, now see the difference. Sigma x bar is equal to sigma upon under root n. After selecting a sample, one would like to go for estimating the value of population parameter, testing a statistical hypothesis about the population, comparing two or more populations, and performing correlation and regression analysis. This all we are going to discuss today. Now comes your sampling distribution. Sample statistics is a function of n samples value x1, x2 till xn. Sampling statistics is a random variable and therefore has a probability distribution or a probability distribution function. It is also known as sampling distribution of the statistic. Sample statistics from the basis of all the inferences are drawn about population. Population probability distribution of the sample statistics allow us to calculate the probability that the sample statistics assumes a particular value. You have seen that how probability distribution is made, drawn. This ability to calculate the probability that the sample statistics lies in a particular interval is the most important factor in all statistical inferences. Now see, sample is x1 till xn. Your sample mean will be summation of all the terms divided by number of terms. This is the basic. From another sample of size n and from the same population, we might get a totally different set of sample values and so a different sample. There are many, perhaps infinite possible values of sample mean. Population infinitely large. Population mean is mu and population variance is sigma square, and sampling is without replacement. The standard deviation, see the mathematical notation, that is the most important part, because at the numerical won't be, it will be an application of these things only. The standard deviation or sample mean is also called the standard error of the mean. The standard error of the mean indicates the extent to which the observed value of the sample mean can be away from the true value due to the sampling errors. Variation क्यों होगा? Error की वजह से. So mathematically it is written as E x bar is equal to mu and variance along x bar is equal to sigma square upon n. And your standard error of the mean, that is sigma x bar, is equal to sigma upon under root n. Now population is finite. Population mean is mu and population variance is sigma square, and sampling is without replacement. Earlier it was with replacement, now it is without replacement. Now see the changes which has occurred in the formula. Here random variables do not remain independent. So E sigma bar is equal to mu, and for the variance, it has become, earlier it was sigma square by n. Now it is being multiplied by a factor n minus n upon n minus 1. And similarly, the standard error of the mean is changed, and in under another under root n minus n upon n minus 1 is there, which is also known as population multiplier. Sampling from normal population. This is basically denoted as x tends to n mu sigma square. We will be considering this only. Then it follows sigma square. But see the change? X bar has been calculated as n mu sigma square by n. The normal distribution is a continuous distribution, and so the population cannot be small and finite if it is distributed normally. Can anyone of you can tell me what is exactly normal distribution is? Any one of you who can tell me what is meant by normal distribution? Under what condition you can say that it's normally distributed?
Normal distribution, the samples which will be equally distributed from both sides, left and right, and having a median, like it will follow the bell curve.
Okay. Anyone else? Yesterday I showed you a bell-shaped graph, and we were talking that here mean, mode, and median will be equal. And then we started z square, z test. That was x minus mu upon sigma. Yesterday we did that in probability. No idea.
Yes, yes, sir.
There were three numericals related to probability, and they all were related to normal distribution. You have to be cautious because now the thing is that I will be using the mathematical concept of probability normal distribution, and you will be seeing how these words are utilized in actual application. Now see to the problem, because we will be talking about the probability, because we will be doing sampling, and once we are doing sampling, we are into the concept of probability. Now suppose the diameter of a component produced on a semi-automatic machine is known to be distributed normally with the mean of 10 mm and standard deviation of 0.1 mm. If we pick up a random sample of size 5, what is the probability that the sample mean will be between 9.95 mm and 10.05 mm? Can any one of you tell me what is the difference between this problem and what we did last night, if you remember? My basic thing is that to make you understand what the problem is and how the problem can be solved and what is the information what we have and how to apply it. Any one of you who remembers the difference between the problem that was discussed yesterday and the problem which is being shown to you right now? I tell you that there is a difference of that, a sentence only. That's everything. If I'm going to remove that, it will become a normal problem. And it, no doubt, It is a normal problem, but here is a component which is included in this problem. And yesterday that was not there.
A random sample of size 5.
Okay, this is the difference. If I remove this will become a normal problem. Now, if a sample size of 5 is included, now see the difference. What is the difference in this? You can see there is a difference of this. Now, this has become this. This is the difference. This, earlier it was this, and now this is not going to change. The standard deviation which changes. ये change हो गया है यहाँ पर. Now, to the problem, 9.95 and 10.05. That means 9.95 should be less than x bar, should be less than 10.05. Replace this with z. Z is what? This x bar minus mu upon sigma. But now we are talking about this 5. So it will be in the denominator under root 5. So here everything will change. 9.95 minus mean is 10. Standard deviation is 0.1 divided by a sample size of 5. Correct? This is here, and the second 10.05 minus 10 upon 0.5 divided by under root 5. Solve it. You will get negative 1.12 and 1.12. That means 1.12 on the negative side and 1.12 on the right side. That means that is a replica. So what we can do, we can convert this into 2 times of 0 less than z less than 1.12. The value of 1.12 will be given to you. That is 0.6 multiplied by 2. You are going to get 0.7372. Probability answer has been told to you, it will always be less than 1. That means a simple statement. This sentence was not there. If you pick up a random sample of size 5. But today, since we are doing sampling, so we have to take the word into consideration, that is sample. Concept remains the same. Concept is this. Yesterday we did this, and today we have added this. Okay? But here it's not required to draw the normal graph. Here it comes. Central limit theorem. Let x1, x2 be xn be the random variables which are independent and having the same distribution with mean and standard deviation. If n tends to infinity, the limiting distribution of standardized mean will be. Now see the difference? Just now we have done z is equal to x bar minus mu upon sigma upon under root n and is a standard normal variant. A sample size larger than 30 is generally considered to be large enough. Keep this thing in mind. Now we move to students' t-test. Must see only the difference. What is the difference in methodology, in the formulas? What has been taught to you are being modified. In actual practice, the value of population standard deviation is sigma is often unknown, and which makes it necessary to replace this with an estimate, usually by S, the sample standard deviation. Now see the difference. X bar minus mu upon sigma upon under root n has been replaced by, this sigma has been replaced by S. X bar minus mu upon x divided by under root n. Exact sampling distribution of this is given by T distribution. It's not mandatory, you have to remember this. It's not required and it won't be there. Nothing like T sort or Z type. This won't be in the problem, but you have to analyze it. What test has to be done? Now, if X is a random variable having the standard normal distribution and Y is a random variable having a chi-square distribution with a new degrees of freedom, and if X and Y are independent, then the random variable T is equal to X upon under root of Y by nu, has a distribution called T distribution or student's T distribution with न्यू डिग्री ऑफ फ्रीडम। अभी ची स्क्वायर टेस्ट लास्ट में आएगा। There are many T distributions, each with degree of freedom, which is the only parameter of this distribution. At a T distribution is similar to standard normal distribution that is shown in the figure below, only if it is flatter and wider, thus having long tail. You can see that there are three bell-shaped figures. Two are solid figures, and the third one is the middle one is in dotted. So what does that mean? As the degree of freedoms are increasing, the graph is shifting towards normal. That means the top one here, it is a standard normal distribution, T distribution with infinity degree of freedom. If we have 1 degree of freedom, if we have 3 degree of freedom, so it's steeper. But when the degree of freedoms have been increased, its peak is climbing up. As the degree of freedom increases, the T distribution comes closer to the standard normal distribution. And when the degree of freedom becomes infinitely large, the T distribution and the Z distribution becomes indistinguishable. You have to keep degree of freedom as many as possible. Now for T distribution, in practice, we conclude that x bar minus mu upon s time divided by under root n would have a T distribution with n minus 1 degree of freedom. It is therefore possible to know the sampling distribution of x even when sigma is not known. हम ऐसे काम कर लेंगे. This result is really useful when the sample size is not large. As we have seen earlier, if the sample size n is large, the T distribution with large degree of freedoms can be approximated by Z distribution. है ना, डिग्री ऑफ फ्रीडम बढ़ाइए तो आपका जो ग्राफ है वो स्टीपर बनेगा, उसकी पीक ज्यादा होगी, एंड दैट विल बी equivalent as Z distribution. If T distribution is used when the degree of freedoms are not larger than 30. If the degree of freedoms are larger than 30, then T test is approximated by standard normal or Z distribution. See the change? Sampling distribution of the proportion is if n is sufficiently large. So you see, earlier it was x, now it is p bar. It tends to n, p into 1 minus p upon n. 1 minus p is what? Q. This approximation works quite well if n is sufficiently large so that both np and n1 minus p are at the least as large as 5. Interval estimation. Suppose we want to estimate the mean income of a population of households residing in a part of city. We might proceed by picking up a random sample of 100 households from the population and calculate the sample mean. That is what we are doing. We are finding the mean income of 100 sample households. In the absence of any other information, a sample mean can be used as a point estimate of the population mean. I hope you are aware of how mean is calculated. We did it yesterday. The lower the standard error of the mean, the greater is the confidence on the correctness of our estimation. This process is further refined in interval estimation, wherein we present our estimate as an interval and quantify our confidence so that the true population parameter is contained by the estimated interval. Now the thing is that what is meant by confidence interval? The probability that the interval estimate will contain the true value of the population parameter that is being estimated. If we say that 95% confidence interval for the population, the mean is obtained by spanning 1.96 times the standard error. Yesterday we talked about one standard error, one standard deviation, two standard deviation, three standard deviation. This is the same that thing. Again, I'm repeating, if we say that 95% confidence interval for the population mean is obtained by spanning 1.96 times the standard error of the mean on either sides of the sample mean. We mean that if we take a large number of samples of size n, say 1000, and obtain the interval estimates from each of these 1000 samples, and then 95% of these intervals estimates would contain the true population. Now, confidence interval for the population mean. See to the problem and why we are doing and how it is done. Suppose it is known that weight of cement in packed bags is distributed normally with standard deviation of 0.2 kg. A sample of 25 bags is picked up at random and mean weight of cement in these is 25 bags is only 49.7 kg. कंपनी क्लेम कितना करती है 50. टेक्निकली रैंडम जो आपने पिक किए 25 सैंपल्स उसके अंदर कितना मिला आपको 49.7. वी वांट टू फाइंड आउट a 90% confidence limit interval for the mean weight of the cement in filled bags. Now the thing is that it is given that this is a problem related to normal distribution. That means X is distributed normally with a standard deviation of 0.2 kg. Same is given in the problem. Now the standard error about the mean, because in the problem mean is standard deviation. We have to take mean because it is written that the mean weight of 25 kg is 49.7. So we are calculating error now in terms of mean. Sigma x bar is equal to sigma upon under root n. So sigma is 0.2 divided by 25 of under root of 25. That comes out to be 0.04 kg. Now what to do? Now since n is less than 30, we will use t distribution. T distribution को use करना है तो हमें z variate लाना पड़ेगा. So t is equal to x bar minus mu upon sigma upon under root n. I hope everything is given to you. Only mu is unknown. That means the mean is mu is unknown. From this you have to calculate mean. Now some of you might be thinking of why this 49.7 plus minus 1.645 is written. How many of you have this question in your mind? You can see it is written over there that mu is equal to 49.7 plus minus 1.645 into 0.04. I just want to know how many of you are aware of why this plus minus is written in this. No idea.
No, sir.
Under root 25 means what?
Plus minus 5.
तो अभी तो आप कह रही हैं नो आइडिया और अभी मैं पूछ रहा हूँ अंडर रूट 25 तो आप प्लस माइनस 5 कह रहे हो. तो भाई
Okay, sir.
ये प्लस माइनस 5 उसी ये +-5 उसी का तो है। तो जब आप इसे सिंप्लीफाई करोगे तो आप क्या टेक्निकली आप क्या करेंगे, वो आपका √525 जो है +-5 बनेगा, और फिर आप +-5 को डिवाइड करेंगे, 0.2 को डिवाइड करेंगे +-5 से, और वो डिवाइड होने के बाद मल्टीप्लाई होगा 1.645 से, इसलिए आपको वहां पर प्लस माइनस दिख रहा है। और ये 49.7, ये म्यू इधर चला जाएगा, और बाकी जो नंबर आया था आफ्टर कैलकुलेशन दैट विल कम ऑन द राइट साइड. So that is why mu will be equal to 49.7 plus minus 1.645. When you are going to calculate it, you will get a value of 49.63 and 49.76. That is with 90% of confidence limit. Okay. Now we will be talking about sample size. As a matter of practice, statisticians usually consider sample size of 30 or more to be large. In the large sample size, we use 95% confidence interval estimate for the population with a mean which is given by x bar plus minus 1.96 sigma upon under root n. Now we will be calculating sample size for estimating population mean. We assume that the population distribution is normal and the population standard deviation is known. In such a case, the sample size required for a given confidence level and a required accuracy can be easily determined. Now the question is how? Suppose we know that the weight of cement in filled bags is distributed normally with a standard deviation of 0.2 kg. Now we want to know how large a sample should be taken so that the mean weight of the cement in a filled bag has been estimated within plus or minus 0.05 kg of the true value with a confidence of 90%. We have seen this formula x bar plus minus 1.645 times sigma upon under root n, which contains the true value of the population with 90% of the time. We also want that interval x plus minus 0.05 should give us 90% confidence level. What now has to be done? Here it comes. 1.645 times sigma upon under root n is equal to 0.05. This is given to you in the problem. Now you have to calculate under root n. Very simple. Square both the sides. Under root will go. 1.645 will be squared. Sigma is 0.2. That will be squared. And it will be divided by 0.05 whole square. You will be left with this. After calculation, you will get 43.3. Or we can say that sample size should be at least 44, so that the mean weight of the cement in the filled bag can be estimated within plus or minus 0.05 kg of the true value with 90% confidence level. Now, testing of hypothesis. I'm telling you, this testing of hypothesis, what we are doing, what right now, same thing will appear in your MMPC 15 also. That time, a semester might have gone. That means that will be in MMPC 15 will be in third semester. So be careful. Try to understand what I'm talking to you right now. What this testing of hypothesis means. Study a class of problem where the decision made by a decision maker depends primarily on the strength of the evidence thrown up by a random sample drawn from a population. A test To test a hypothesis, a statistical procedure is followed, and this procedure is known as testing of hypothesis. Now the question is, what is hypothesis is? A hypothesis, or more specifically a statistical hypothesis, is some statement about a population parameter or about a population distribution. If the population is large, the hypothesis is tested on the basis of the outcome of a random sample. A hypothesis is a statement about a population parameter or about a population distribution. In any testing of hypothesis problem, we are faced with a pair of hypotheses, such that one and the only one of them is always true. One of this pair is called the null hypothesis, and the other one is known as alternate hypothesis. The null hypothesis is represented by H naught. This zero comes in the subscript. And the alternate hypothesis is represented by H1. What is null hypothesis? The null hypothesis is called by this name because in many situations, acceptance of this hypothesis would lead to null action. Rejecting the null hypothesis leads to a change in status quantum. वो नहीं होगा तो ये होगा. If the population mean is represented by weak mu, we can set up our hypothesis S. Suppose in general, this is a very general statement. H naught is to mu, it's written in this way only. H naught is to mu is equal to 20. And the alternate hypothesis will be, it is greater than 20. Two things are there. If we have presented symbolically above, can be interpreted to mean that the null hypothesis is that the population mean is not greater than 20, whereas the alternate hypothesis is the population mean is greater than 20. It is clear that both H0 and H1 cannot be true, and also that one of them will always be true. See, this is hypothesis, concept of hypothesis. At the end of our testing procedure, we have come to the conclusion that H0 should be rejected. This also amounts to saying that H1 should be accepted and vice versa. But this is the basic standard statement. What does hypothesis procedure means and how it has to be answered? We will see in the problem how it is calculated. But just right now we are discussing about the terminology and the concept of hypothesis. There are two types of error which normally occurs. Now, how does that error occur and what does that mean? And if the error has been done or made in the judgment, then how it will affect the organization. This we will see. If we wrongly reject H naught, when in reality H naught is true, the error is called type 1 error. Similarly, when we wrongly accept H naught, when H naught is false, this is known as type 2 error. You can see what does this mean. Which way? That is above is the statement, and in the lower the slide it is drawn in the figure. Which way you want? If H naught, we accept H naught is true, and we reject H naught, it is type 1 error. But if H naught is false and we accept, we say that this is we reject H naught, then that is a type 2 error. Now let us see practically what does this hypothesis is correlated to a problem. Again, the statement of the problem is confusing, but you have to understand it's very interesting problem. It's not confusing, rather, it's very interesting. Now let us take a situation where a patient suffering from high fever reaches to a doctor. And I hope the problem what I'm discussing over here has occurred with every one of us. Now let us take a situation where a patient suffering from high fever reaches to a doctor. And suppose the doctor formulates the null hypothesis and alternate hypothesis S. H naught, the patient is a malaria patient, and alternate, the patient is not a malaria patient. यही दो चीजें एग्जिस्ट करेंगी. डॉक्टर ने अभी कुछ नहीं किया, सिंपली आपने ये कहा उससे कि आई एम सफरिंग फ्रॉम हाई फीवर. तो डॉक्टर इंस्टेंटली in doctor's mind it came that you might you are suffering from malaria. He is not confident, and the alternate hypothesis is that you are not suffering from malaria or you are having any other cause of the fever. Case 1. Suppose the hypothesis H naught is really true. That is, patient actually a malaria patient, and after observation, pathological and clinical examination, the doctor rejects H naught. That is, he or she declares him a non-malaria patient. It is not a correct decision, and he or she commits an error in decision of type 1 error. What happened in case 2? Suppose the hypothesis H naught is actually false. That is, patient actually a non-malaria patient, and after observation, the doctor rejects H naught. That he or she declares him a non-malaria patient. It is a correct decision. Case 3 is, suppose the hypothesis H naught is really true. That is, patient actually a malaria patient, and after observation, the doctor does not reject H naught. That is, he or she declares him a malaria patient. It is a correct decision. But in fourth case, what is happening? Suppose the hypothesis H naught is actually false. That is, patient actually a non-malaria patient, and after observation, the doctor does not reject H naught. That he or she declares him a malaria patient. It is not a correct decision, and he or she, the doctor, has committed an error in decision of type 2 error. These are the four cases which normally occurs. Now, in general, we have taken this. Normally, what happens? If you are having high fever, with the experienced doctor straight away say that you are suffering from malaria. But actually, you being an intellectual, so what you are going to say? You can ask doctor, sir, why don't you go for a test, something pathological? And if he says no, it's true that I said malaria, you are a malaria patient, but actually you are not a malaria patient. If you accept that you are a malaria patient, that the original hypothesis is correct. So that is why these are the four cases which are generated, and how what is meant by type 1 error and what is meant by type 2 error has been discussed. This is normally based, one should be aware of, because here, under the circumstances of decision making, this concept is used. Type 1 and type 2 error, both these errors are bad and should be reduced to minimum. For a given sample size, these two errors neutralize each other. If the testing procedure is designed as to reduce the probability of occurrence of type 1 error, simultaneously the probability of type 2 error would go up and vice versa. What can be at best be achieved is a reasonable balance between these two errors. Type 1 error is much more severe than type 2 error, and so needs to be controlled. Type 1 error generally results in financial loss to the company, and type 2 generally results in an opportunity loss to the company. Significance level. Probability of type 1 error needs to be controlled. This is done through specifying a significance level at which a test is conducted. The significance level therefore sets a limit to the probability type 1 error and test the procedures are designed so that to get the lowest probability of type 2 error subject to the significance level. The probability of type 1 error is usually represented by a symbol alpha, and the probability of type 2 is represented by beta. Testing of hypothesis suffers from the limitation that the financial or the economic cost of consequences are not considered explicitly. In practice, the significance level is supposed to be arrived at an early at after considering the cost consequences. It is very difficult to specify the ideal value of alpha. Probability of type 1 should be lower. That is, the value of alpha should be lower. In practice, most tests are conducted at alpha is equal to 0.01, alpha is equal to 0.05, or alpha is equal to 1 by convention as well as by convenience. So normally, I don't know how many problems of hypothesis testing or sampling you people have seen, but normally in the problem it is written that using test of confidence of 0.01 or 0.05. Now see, at the center it is 0.99, assuming to be 1. If we talk about 0.005, it is at the right. And for negative part, it will be at negative 0.005. One often accept a null hypothesis. We reject a null hypothesis even when it is false. This is the classical condition of that. That is type 1 error and the relation between type 1 error and alpha. आप देख रहे हैं it is very broad. The maximum part is included in it. So that means we have to take the value of alpha as 0.005. Now what is happening over here? Rarely accept a null hypothesis, often reject a null hypothesis when it is true. It's coming closer. That region becomes 0.25. Now see the example. We are talking about testing of a chemical. If wrong inferences is drawn, whole group of users will be poisoned. Prefer high significance level, that is high probability of type 1 error, and reject H0 when it is true. Second problem is reassembling a big machine. If wrong inferences is drawn, some parts may be repaired or replaced. Prefer low significance level and high probability of type 2 error. H0 even if it is false. भाई रिप्लेसमेंट की जरूरत नहीं है, रीअसेंबली करनी नहीं है, फिर भी आप करवा रहे हो, तो कितना इकोनॉमिक कॉस्ट और लॉस हो रहा है उससे। इस चीज की जरूरत नहीं है एंड यू आर परफॉर्मिंग इट। Now see what does this actually means. 5%. We are talking about effectiveness of drug. H0 had no effect and H1 has effect. The mean is between plus minus 1.96 of standard deviation, and your level of significance is 5%. Except means 5% level of significance. Data does not allow us to reject a null hypothesis. So that is in this region only. The power curve of a test. Calculate the probability of rejecting H0 for different values of mu and plot these on the graphs. Such a curve is known as power curve of the test. Here your null hypothesis is that mu is less than equal to 20. And your alternate hypothesis is that mu is greater than 20. This graph, what is seen, is a power graph or power curve. P value of a test. The significance level is arbitrarily fixed. A better way of expressing the conclusion of test is to state the p-value of the or the probability value of the test. P-value of test expresses the probability of observing a sample statistics as extreme as one observed if the null hypothesis is true. Now comes hypothesis testing procedure. There are basically two phases in testing of hypothesis. In the first phase, we design the test and set up the condition under which we shall reject the null hypothesis. In the second phase, we use the test based on the sample evidence and draw a conclusion as to whether the null hypothesis can be rejected or else what is the p-value of the test. Step number one, state the null and alternate hypothesis. That means you have to define H0 and H1. Choose the test statistics that is the sample statistics that will define the critical region. Specify the level of significance of alpha. Define the critical region in terms of the test statistic. Fifth one is compare the observed value of the test statistic with the cutoff value of or the critical value and decide to accept or reject the null hypothesis. Now these are the 5 steps. Now we will see how these 5 steps are implemented in the problem. Why it is needed? Inspections sometimes do not allow inferences. For example, a manager comments that average work efficiency is 90%. Suppose our calculations gives the result as 95%, we accept it. 40% we reject it. And 89% we have to apply some thought. This is what mathematics says. Intuition does not work. So one has to decide on the basis of sample information. The past experience says this. This is a phrase which is normally used by mathematicians, statisticians, because they have to consider the factor of the past also. That is true that intuition does not work all the times. Testing the population mean. Under different conditions, the test procedure have to be developed differently. There are many cases like when the population variance is known or unknown. See the condition. We have to decide whatever is given to us, what is known to us. We know what we are supposed to do, but we have to see which information is with us. So then only we can proceed further. When the population variance is known or unknown, when the distribution of sample size Z can be approximated by a normal distribution or not, when test is two-tailed or one-tailed test. Now see, we'll see how this is done. Normal distribution or T distribution. See to it, when sample size is large, 1030, what we are going to do. And when population SD is known, we apply Z test. When population SD is unknown, we apply Z test. When the sample size is larger than 30 and population SD is known, we apply Z test. But when population SD is not known and the sample size is greater than 30, so we use T test. This is how we have to remember when to use, under what condition to use Z test. To see out of the 4 conditions, we are using Z test in 3. That means we have to keep Z test in our mind unless and until T is required to be calculated. A bulb manufacturer rejects if life is short, that is of bad quality. and rejects if life is very high, large population production cost. For wholesaler, reject if life is shorter, bad quality, and accept otherwise. Who is bothered about the cost? See the difference. How the manufacturer thinks and how a wholesaler who's selling your product thinks. See the difference in both the graphs and both the conditions. And see one sign is used. In H naught, we have to use equal to sign, and in H1, the alternate, we can use either greater than, less than, or not equal to. Now see, this is a condition when standard deviation is known. In the problem, standard deviation is given to you. The problem is related to a rim manufacturer. Condition must withstand that the rim can withstand a load of 80,000 per kg per square inch. Standard deviation is 4,000 kg per square inch and mean is 79,600 kg per square inch. We have to identify what is H and what is H1, and what is H naught, what is H. Now see to the first line. N is 100, that is given in the problem. H naught is, condition is it can withstand of that much of load. That means H naught is to mu is equal to 80,000. And the alternate is it cannot. The H1 is to mu is not equal to 80,000. Your alpha is 0.05. If it is not mentioned, you can take 0.05. Now standard error of the mean, that is sigma upon under root n. This comes out to be 400. And Z calculated will be calculated. Now the thing is that you have to come to a conclusion. When have to come to a conclusion, then you have to see the calculated value and the tabular value. Tabular value will be given to you in the problem. Now if how the conclusion is drawn, if your Z calculated is less than Z tabular, accept it. Accept the hypothesis. That is, accept the null hypothesis. And if Z calculated is greater than Z tabular, you have to reject the hypothesis. Keep that thing in mind. My every solution, the last line, which is marked in red, is very critical because that only is the conclusion or the answer of the solution. Now this is testing the promotability of employees. H naught is roughly 80% are promotable. तो alternate क्या हो गया? नहीं होंगे. That means alternate में क्या हो गया? Remaining 20%. Committee finds only 70% are promotable. That means your P is 0.7 and your Q will become 0.3. So you have to use that formula. Standard of error of mean is calculated, and then you have to calculate Z calculated. As Z calculated here will be calculated by probability. Same. You have calculated Z calculated. Value of Z by calculation. If Z calculated is less than tabular form, accept it. And if it is greater than, then reject it. Now when standard deviation is not known, you see the problem? Can anyone tell me if standard deviation is not known, then what will you do? If standard deviation sigma is not given to you, then what will you choose to do? I have already told you sigma is not given, then what has to be taken? Problem cannot be left as such. No idea.
Sir, here is it written replace sigma by S.
तो मैडम आपसे आधे घंटे पहले मैंने यही तो बताया था कि अगर सिग्मा नहीं है तो प्रॉब्लम के अंदर एस होगा, एस से रिप्लेस कर देना, और यही मैंने यहाँ लिखा है सॉल्यूशन में। मैं वही तो पूछ रहा हूँ और आपको बता रहा हूँ कि ये प्रॉब्लम के अंदर एस डी नहीं है तो क्या करोगे, यही तो मैं पूछ रहा हूँ। भाई हमारी थ्योरी कहती है सिग्मा एक्स बार इज इक्वल टू सिग्मा अपॉन अंडर रूट एन, बट हमारे पास सिग्मा तो है ही नहीं, देन व्हाट टू डू? अब आप ऊपर वाली लाइन में देखिए, इट इज रिटन एस इज इक्वल टू 11 and alpha is 0.1. Everything is given to you. You have to just replace the conditions in the placing up of the formula. Rest everything will be like that only. Now if t calculated is less than t tabular, accept it. If t calculated is greater than t tabular, then reject it. Now comes ची स्क्वायर टेस्ट। मैंने अभी थोड़ी देर पहले कहा था, एक जगह मैंने इसे यूज किया था डिग्री ऑफ फ्रीडम के अंदर। अब मैं यहाँ पे आपको ची टेस्ट बताऊंगा। If required, the equality of variances could be tested. We can also test if the population distribution is really normal. We can test whether the population distribution is Poisson, exponential, or any other known population. We can test if two samples are independent. Here, under what conditions chi-square test is used. These are the conditions when chi-square test is used, can be used. Now see, degree of freedom. I told you that as degree of freedom increases, the graph becomes steeper. That means it shifts itself towards the normal distribution, behaves like or shifts towards normal distribution. If 1 degree of freedom is there, then you can see a parabolic coming down, an arc which is coming down. If degree of freedom is 5, this graph has moved up, the second one. And if degree of freedom are 10, it is similar to that of normal distribution. What are the properties of chi-square? If x is a random variable having a standard normal distribution, then chi-square will have a chi-square distribution with 1 degree of freedom. If y1 and y2 are independent random variables having chi-square distribution of chi1 and 1 v2 degree of freedom respectively, then y1 plus y2 will have a chi-square distribution of v1 plus v2 degree of freedom. टेक्निकली टी स्क्वायर डिस्ट्रीब्यूशन का फॉर्मूला क्या होता है? n-1 s square upon sigma square for n-1 डिग्री ऑफ फ्रीडम। अब मैं इस फॉर्मूले को चेंज करूंगा और आपको ये दिखाऊंगा कि इस फॉर्मूले को फॉर्मूला देख लीजिए आप, n-1 into s square by sigma square has a chi square distribution on n-1 degree of freedom. We will see how this is used. A TV channel program manager wants to know whether there are significant differences among the male and female viewers between the type of the program they watch. A survey was conducted for the purpose and it gave the following results. TV programs, and we have been talking about male and female, so we have to fill up the data. We are talking about two programs, that is news and serials. If we talk about news, 30 males people were found that they were interested in news, and 10 female were found that they are interested in watching news. And for serials, it was 20 and 40. Now, when we sum up male, we got 50, and when we sum up females, we got 50. That means the sample size was of 100 people. If we total them along the news, it becomes 40, and for the serials, it becomes 60. That means everything seems to be in order. Now we calculate G-squared statistics and determine whether the type of TV program is independent of the viewer sex, and we take 0 alpha is equal to 0.10 significant level. Now how to proceed? First of all, null hypothesis and alternate hypothesis has to be formulated. So your null hypothesis will be the viewer sex is independent of the type of TV program. That means there is no association among the male and female viewers. And the alternate will be the viewer sex is not independent of the type of TV program. Now, here you can see that we are given 4 informations. That means 2 information related to news and serials, and 2 is in terms of their sex, that is male and female. So in that case, we have to calculate expected frequency, because probability can only be found out when we know the actual number of frequency. In that case, how that expected frequency is calculated. Observed frequency, listen to it what I'm saying. Observed frequency is given to you, and you have to calculate expected frequency. And how it is calculated? It is the row total into column total upon total. Now the question arises how this E will be calculated. See to it. E is what? Row total into column total upon 100. The problem is given to you in the second block. But now you are calculating E of it. E is calculated as row total is 40, column total is 50. 40 into 50 divided by 100. So the value you get 20 in the second one, again 20. For serials, it is 30 and 30. Total up 50. For the females, it is again 50. And for TV programs, it is 40. And for serials, it is 60. My calculations are correct. Now we will be converting this information into O and E, because we have to calculate G square. Column 1 and column 2. Column 1 and row 1. In the left hand side bracket, you can see 1 1. It is row 1, column 1. वहाँ पे आपका 30 था, 30, 20, 10, 40. What was given to you? 30, 20, 10, 40 was given to you. You have calculated E for all these 4 values, which comes out to be 20, 30, 20, and 30. Now, you have to calculate O minus E, यानी कि observed value minus expected value. The difference comes out to be 10. And the second one minus 10. Third one minus 10. The fourth one 10. Square these. 10 square will be 100 in all the 4 terms. Now the last column is O minus E whole square divided by E. What it will come? 100 divided by 20. 100 divided by 20 is 5. 100 divided by 30 is 3.99. And 100 divided by 20 is 5. And 100 divided by 30 is 3.33. Add up. What you get? 16.66. This is known as chi-square value. How many terms are there? 4 or 3 or 2? भाई कॉलम के अंदर कितने थे? डिग्री ऑफ फ्रीडम निकालना है, 2/2 टेबल है, तो आपका हो जाएगा 2 - 1 into 2 - 1, that is 1. So that means you have to, in the problem, the statement will be the information. Chi-square will be 2.706 at degree of freedom of 1. You have calculated degree of freedom as 1, and at significant level of 0.1, your tabular value is 2.706. And what you have calculated? 16.66. Observed value is greater than tabular value. यानी कि calculated value is greater than tabular value. आप रिजेक्ट करेंगे. 16.66 is greater than the tabular value of 2.706. We reject the null hypothesis and conclude that type of T program is dependent on the viewer's sex. It should therefore be noted that the value of chi-square is greater than the tabular value of chi-square. The difference between the theory and observation is significant. And normally what happens, it will be difficult for you people to understand when to apply this formula or this concept chi-square. It won't be written over there. Just have a look on the problem again. Go through the statement of the problem. We are using the purpose of or the properties of probability and normal distribution. But here there is a change in the formula. That is O minus E whole square divided by E has to be calculated for all the 4 observations. This was the problem given to you. That means these 4 values were the observed value, and these numbers are your expected frequency. For that, after that, you are converting this into this. 1 means this column, 1 2 means this column, 2 1 means this column, and 2 2 means this value. Your chi-square is 16.66, what you have calculated, and your tabular value is 2.706. Keep one thing in mind. In chi-square test, we have to use degree of freedom. And for calculating degree of freedom, that is row -1 into column -1. There are 2 rows, 2 columns. 2 - 1 is 1, and 2 - 1 is 1. 1 into 1 is 1. Therefore, your degree of freedom will be 1. And for degree of freedom of 1 and at level of significance of 0.1, your tabular value is 2.706, which is much lower than the calculated value. Therefore, we will be rejecting null hypothesis. Testing the goodness of fit. The chi-square goodness of fit is statistical hypothesis test used to determine whether a variable is likely to come from a specified distribution or not. It is often used to evaluate whether a sample data is representative of the full population. A goodness of fit test is typically used to determine if data fits a particular distribution. The test of independence makes use of a contingency table to determine the independence of the 2 factors. The 2 are sometimes confused, but they are quite different. The chi-square test for the independent compares 2 sets of data to see if there is a relationship. A chi-square test goodness fit is to fit one categorical variable to a distribution. Suppose we want to test if a worker is equally prone to producing defective components throughout an 8-hour shift or not. We break the shift into 4 2-hour slots and count the number of defective components produced in each of these shops. At the end of 1 week, we find that the worker has produced 50 defective components with the following breakup. Now, see. Expected slot 8 to 10, 10 to 12, 12 to 12:30 to 14:30, and 14:30 to 16:30. Your observed frequency is 8, 11, 16, 15, and the sum is 50. Using a significance level of 0.05, is it reasonable to assume that the probability to produce a defective component is equal in each of the 4 slots? It's very difficult to say after having a look on this. 8 to 11 is difference of 3, 11 to 16 difference of 5, and 16 to 15 difference of 1. So we cannot say with the experience or with the information given to us. Now we have to move one step forward to prove it for actual condition. Now here it comes. We have to calculate that there are 4 slots. See the change in the problem, but that is the solution. H0 is equal to P1 is equal to P2 is equal to P3 is equal to P4, and that is equal to 0.25. That means there are 4 slots and we are taking one at a time. 1 by 4 is 0.25. And alternatives, H1 is, it's not equal. All the 4 are not equal. We have been provided with observed frequency. Now we have to calculate expected frequency. The similar method what we performed in the earlier has to be applied over here also. That was row total into column total upon total. So here you get 12.50, 12.50, 12.50 and 12.50. That is the expected frequency. आप total कर रहे हैं तो it comes out to be 50. Correct. Find out O minus E. Then find out O minus E whole square. And then find out O minus E whole square divided by E. What we get? We get a value of 3.28 after adding all these. Now what is the tabular value? In the above table, the expected frequency have been calculated as NP, where N is the total frequency, which is 50, and probability of each one is 1.1 by 4, that is 0.25, under the null hypothesis. There are 4 degree observations are 4. Your degree of freedom will be 4 minus 1, that is 3. For 3 degree of freedom at 0.05 value, the tabular value should be 7.815. But your calculated value is less than the tabulated value. What will be the answer? To accept the hypothesis or to reject the hypothesis? Your calculated value is 3.28 and your tabular value is 7.815. Will you accept the hypothesis or you will reject the hypothesis? No idea. The calculated value is 3.28 and your tabular value is 7.815. Will you accept the hypothesis or you will reject the hypothesis?
Reject.
Reject. Anyone else? नो आइडिया। अरे इतनी देर से एक ही चीज तो मैं आपको बता रहा हूं कि अगर
Sir,
आपकी
we will accept it.
कैलकुलेटेड
We'll
वैल्यू
accept it, sir.
अगर आपकी कैलकुलेटेड वैल्यू टेबुलर वैल्यू से कम होगी तो आपको एक्सेप्ट करना पड़ेगा। हम एक्सेप्ट कर रहे हैं। इससे पिछले वाली प्रॉब्लम में क्या हुआ था? What happened over here? See what is written. Here you people used to say that mathematics is difficult. I don't understand why it is difficult. Your t-square, what you have calculated is 16.66, which is greater than the tabular value of 2.705. So we reject the null hypothesis. And in this problem, what is happening? Here what happened? Your tabular value is your calculated value is 3.28 and your tabular value is 7.85, so you will accept it. We can reject the null hypothesis only when the observed value of t square statistics is at least 7.815. So we cannot reject the null hypothesis. But when I told you that the last line, the last conclusion will be your answer. आप सबको after doing everything correct, अगर आप conclusion draw गलत करते हो तो think over how much economic loss will be to the company. The last part is testing of hypothesis for two population variants using F-test. Before applying t-test for differences of two population means, one of the requirement is to check the equality of variances of two populations. This assumption can be checked with the help of F-test for the two population variants. For example, an economist may want to test whether the variability in incomes differ in the two populations. A quality controller may want to test whether the quality of the product is changing over time, etc. But these are the examples where it is applied. And what are the assumptions? The assumption of F-test for testing the variance of two populations are: the population from which the samples are drawn must be normally distributed, and the sample must be independent of each other. Now you can ask me questions, because I think your block 3 has been completed now. Any question from anyone?
Sir, will you dwell into the important questions that are likely to appear in the examination? Sir?
This is very difficult to answer, but that is for sure. Whatever we are discussing and whatever I'm telling you and whatever you are listening can be asked. I'm telling you that part only which is really required for the calculation purpose and to understand the subject. And I'm not using any bookish language. I'm not using any formal language as such of. Simply taking up the things what are needed to be understood, which is required, you should be aware of. I'm discussing that part only. And in the second half, that will be much, much more interesting. Whatever we are discussing or whatever you are listening is important for you.
Right, sir. Thank you, sir.
So we will be meeting in the next section, which will start at 6:15. Okay.
Right, sir. Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Okay, sir. Thank you.